Basic principles of forensic chemistry as a tool in criminal investigation.
Forensic chemistry is the analytic study or substances that could be easily misidentified or confused, and finding their identity. Forensic chemists analyze the physical and chemical properties of different materials in order to identify them correctly, where one or more materials may have similar properties. So, forensic chemistry and forensic science is the same? The answer is no. It's because forensic science and forensic chemistry are not the same. Forensic science is all laboratory research that helps with a criminal investigation. Forensic chemistry is a part of forensic science. Forensic chemistry is the part of forensic science that identifies substances to solve a crime. The main contribution of forensic chemistry to criminal investigation is where the forensic chemist analyze non-biological trace evidence found at crime scenes in order to identify unknown materials and match samples to known substances. They also analyze drugs-controlled substances taken from scenes and people in order to identify and sometimes quantity of these materials. And next, these are the basic principles of forensic chemistry as a tool of criminal investigation. First is collection of the specimen to be examined. The proper collection, preservation, and transportation of specimens are essential in the investigation of crime. Hence, whenever possible, the chemist should personally collect all the specimens necessary for the examination. There are factors that must be considered when collecting specimen for examination. First is the sufficiency of samples. The collected evidences or specimen must be sufficient rather than insufficient because the chemist will not only examine specimen once, it will take them how many times to properly conduct examination.
Second is the standard for comparison. Example is, if blood is found in linoleum, a sample of unstained blood must be submitted together with the stained portion. Third is maintenance of individuality. Each piece of evidence must be collected and preserved as a separate sample. Lastly is labeling and sealing. It is well settled rule that evidence will have no value in spite of the good report of the expert if the specimen cannot be denied by reason of improper labeling. The second basic principle is the actual examination of the specimen. There are third step that in the actual examination of the specimen, the first step is to scrutinize it carefully and write down in the laboratory logbook the particulars of sealing. Second step, measure or weigh the objects, and all measurements and weights must be entered in the laboratory logbook. Third step, in the laboratory examination, which consists of chemical, physical, and confirmatory tests. The third basic principle of forensic chemistry as a tool of criminal investigation is the communication of the results of the examination. The results of the examination conducted should be communicated with the requesting party in the form of written report, which must include an enumeration of facts on the specimen received for examination with detailed description of the packaging, sealing and labeling, date of receipt and from whom it was received, the purpose of the examination, the finding and conclusion. The last basic principle of forensic chemistry as a tool of criminal investigation is the court appearance. The written report of the forensic chemist is usually supplemented by testimonial evidence in a later date if the case is brought to court or the fiscal's office. Since the testimonial evidence may be given weeks, months, or even years after the examination and the written report have been made, it is not only permissible but indispensable that the chemist should refresh his memory by referring to his laboratory record book before presenting himself in court.
What is scientific evidence? Scientific evidence is most often presented in court by an expert witness testifying as to expert opinions. It also includes expert testimony that goes beyond science. The scientific expert is frequently called upon to interpret results and draw a conclusion about what results mean in the case being tried. So, the uses of scientific evidence. Even though scientific evidence is not infallible, it could contribute to an investigation by it provides a lead or leads to a criminal investigation in the right direction. It provides information illuminating a suspect as the person who committed the crime being investigated. It provides corpus delicti or proof that a crime was committed, providing the independent corroborative evidence necessary to support a confession. It establishes a link between the crime scene and the suspect or between the suspect and the victim of the crime. It provides one of the essential elements of the crime being investigated. It affirms or disapproves an alibi, establishing the innocence of people not involved in the crime. It encourages or induces or a person to make a confession or an incriminating admission when the person is confronted with scientific evidence that incriminates them. It provides a reasonable suspension or probable cause. It builds such strong cases against defendants that the number of guilty pleas are increased, clearing court calendars and permitting faster trials of contested cases.
In general, scientific evidence are the result of scientific tests used to prove or disprove a theory or a hypothesis. In criminal cases, scientific evidence is used to help jurors understand and determine the facts of a case. Some types of scientific evidence used in criminal cases include DNA evidence, fingerprints, voice identification, hair and skin evidence, voice recognition, tire prints, and autopsy reports, which are all relevant to finder of fact. A court's rule of evidence will guide how scientific evidence can be introduced in court, and most times, it will be done through an expert witness.
Before I discuss the different types of physical evidence, let me explain first what is physical evidence. Physical evidence refers to any material items that would be present at the crime scene, on the victims, or found in suspect possession. The term physical evidence involves any physical entity that can furnish some degree of proof or disproof. Physical evidence may be used to establish an element of a crime, such as the presence of an accelerant at the point of origin of a fire in a suspected arson. Physical evidence, also called real evidence, are actual tangible evidence that can be touched and picked up that is relevant to the case. The laboratory findings from the analysis of physical evidence can often be used to induce a confession, exonerate the innocent, check an alibi, and provide investigative leads that may well change the entire direction of the investigation. Physical evidence is one of your most valuable assets in pursuing an investigation to a successful conclusion. It produces leads during the investigation and aids in establishing the guilt or innocence of an accused person in a judicial or administrative proceeding. To achieve the maximum benefit from physical evidence, not only must you be skilled in collecting it, but you must know how to handle and care for it, to preserve it for the development of leads, for laboratory examination, and or for presentation in court. So, there are two kinds of physical evidence. These are the fixed and movable, and it will be discussed by Ms. Hadjan.
Kinds of physical evidence. Fixed and movable. Fixed are those evidence that cannot be moved and or impossible to collect in its entirety for delivery in the laboratory and subsequently presentation in court. Fixed or immovable evidence cannot be readily removed from a crime scene because of its size, shape, makeup, such as walls, telephone poles, and floors. Movable. It can be collected or moved and delivered to the laboratory for examination and can be presented in court in its original form. Movable evidence can be picked up at a crime scene or any other location and transported. Common types of physical evidence. Wounds. Wounds can often be matched to weapons or tool marks on the weapon. Investigators may also be able to determine the weapon size, shape, and length. Analysis of a wound may provide clues to a victim's injuries, characteristic of the suspect, left-handed, right-handed, height, etc., and position of the victim and suspect at the time of the incident. Traces of explosive found on a suspect clothing, skin, hair, or other object may be matched to explosive from the crime scene. Materials used to make an explosive device will compared to evidence found in the suspect's position to confirm a match. DNA. Investigator can extract DNA from almost any tissue, including hair, fingernails, bones, teeth, and body fluids. The DNA is used to create a profile that can be compared to profiles from suspect or victims.
Additionally, the other common types of physical evidence are blood, semen, saliva, hair, human or animal, biological samples. Hairs and fibers. Hairs and fibers may be transferred from the suspect or the suspect's clothes to the victims and vice versa. For example, a suspect may pick up a carpet fibers on his shoes or leave hairs behind at a crime scene. Hairs can be examined to identify their origin, such as human or animal. Hairs with roots intact can be tested for DNA. Fibers are used to make clothing, carpeting, furniture, beds, and blankets. They may be natural fibers from plants or animals or synthetic fibers that are man-made. Shoes and tires will also show wear patterns after being used for a period of time, as well as other features, scratches, nicks, and cuts that can be used to match evidence to specific items. For example, shoe prints can be matched to a suspect based on how the threads on the shoes that are worn down due to the person's walking style. Bite marks. Each of the 32 teeth in humans is unique due to age and wear. Impressions and photographs of bite marks left on a victim, assailant, or other object at a crime scene can often be matched to dental records.
When is the perfect time to collect this physical evidence? What is the right to collect evidence that you can collect the whole help in the identity of the perpetrator of the crime? Where can you find or locate these pieces of physical evidence? Why are you collecting this physical evidence? And lastly, how are you going to collect them? First, photograph the whole crime scene in full view. Example of the type of photograph. First, general view or long range. Second, medium range or mid range. And lastly, close-up view or close-up range. Photography is the primary tool of the crime scene documentation. Proper crime scene photography is deliberate and systematic process. Its main purpose is to visually convey all aspects of the scene to someone who wasn't there. To accomplish this, all crime scene photography consists of three basic of photographs: overall, mid-range, and close-up. Use appropriate tools and materials in collecting physical evidence. They should wear disposable gloves, protecting clothes, disposable hygiene face mask, disposable shoe covers, hair covering, and safety eyewear glasses. These are the necessary tools and equipment for proper collection physical evidences. Collect sufficient sample for complete examination. Obtain known standard like hair, blood samples from victim and suspect. Because when we have sufficient sample, it can reach the required level of precision within the range of sample sizes needed for evaluation, which is extremely important for accurate comparison.
Number 4. Mark each evidence collected for identification and seal the evidence package. Ensure all evidences are secured. Make sure that hiding places or difficult access areas have not been overlooked. The majority of the evidence will be gathered in paper bags, packs, and envelopes. Transporting liquid object is possible with leak-proofs, unbreakable containers. Evidence from fires is typically gathered in sterile, airtight metal cans. Plastic bags should only be used to gather the store significant amounts of dry powder. If the storage time in plastic is 2 hours or less, wet or moist evidence like blood, bloods, and etc. from a crime scene can be collected in plastic containers at the scenes of transported back to an evidence receiving areas. Number 5. Photograph the scenes showing final condition after collection of physical evidence. The process of gathering evidence can start once the crime scene has been fully documented and the location of the evidence have been identified. A collection can be carried on logically or following the trial leading to the murder scenes. If the investigator is uncovering layers of evidence that were previously hidden from view and were not previously documented, more photos should be taken.
Crime laboratory, also called forensic laboratory facility, where analysis are performed on evidence generated by crimes or sometimes civil infractions. Crime laboratories can investigate physical, chemical, biological, or digital evidence and often employ specialists in a variety of disciplines, including behavioral forensic science, forensic pathology, forensic anthropology, crime scene investigation, and ballistics. Many crime labs are publicly funded and administered by federal, state, or provincial or local government, although there are a growing number of private labs that specialize in fields such as drug analysis and DNA fingerprinting. England and Wales are among the few places in the world to have exclusively privatized crime labs. Later on that, the actual scientific work began under the initiative of Dean C. Worcester in 1901 by virtue of Act No. 156 approved by the Civil Commission. Years later, in December 1, 1937, the Division of Investigation was created under the Commonwealth Act No. 181 with 2 medico-legal officers and a chemist. A medico-legal officer can be coroner or medical examiner. In either case, the medico-legal officer is responsible for leading an investigation to determine the circumstances under which someone died.
On September 13, 1887, the Laboratorio Municipal de Manila was established.
Development of scientific crime laboratories internationally and locally. During 1910, one of the early pioneers in establishing forensic science as part of the justice system was founded by Edmond Locard of France. He established the world's first crime laboratory in Paris. And on February 14, 1929, in Chicago, when a massacre occurred, intelligent of group-minded individuals established a crime laboratory because of that incident. And now, during our current era, the FBI Crime Laboratory, also known as the Federal Bureau of Investigation Laboratory, is the most advanced and comprehensive crime laboratory in the whole wide world. Now, let's talk about the development of scientific crime laboratories in our country, which is the Philippines. It all started in the Philippines by the name of
Governor General Joaquin Javier. He was the one who created a committee to study the mineral waters of Luzon during December 15, 1884. Then they appointed Anacleto del Rosario as their chemist. And we all know that a chemist is an expert who engage and practice chemicals.
Audio Jungle.